Solving polynomials. This is where we basically say, okay, if O, then either A equals B 0 or B equals 0. And that is kind of common sense, right? If you multiply two things and the product is going to be 0, then one of them had to have been 0. So when we solve polynomials in factored form, we're solving, meaning x times x minus a equals 0, one of those has to be 0. So let's figure it out. Let's say, okay, if x equals 0, that's 1, or when x minus 8 equals 0. To solve that, you add 8 to both sides, you get x equals 8. Very simple. All right, the second example, 4m plus 8 times m minus 3 equals 0, that would equal 0 when one of these equals 0. So 4m plus 8 equals 0, or m minus 3 equals 0. On the left, when you solve, subtract the 8 and divide by 4, you get m equals negative 2. On the right, add 3, you get m equals 3. So two possible answers. There's a U-try. I'd like you to try that on your note sheet, and we will go over it tomorrow in class. All right, some more examples. If we're not in factored form, if you noticed these two examples, this is factored form, okay? X times x minus 8, 4m plus 8 times m minus 3, those are both factored form. So now if they are not in factored form, you need to factor it first, and then set each factor equal to 0 and solve. For example, how do we factor 5p minus 15p squared? Well, 5 and 15, they both have a 5 in it. P and p squared means we can take a p out. What's left? 5p divided by 5p is 1, so you have 1 minus 15p squared divided by 5p. 5 goes into 15 3 times. P squared and p reduces to a p. Then when you set each of those equal to 0, sorry, I need to move both of these. Oops, it's not letting me move just the part that I want. Bummer. Alright, we'll leave it like that. I'll write it someplace else in a different color. You have over here 5p equals 0 or 1 minus 3p equals 0. Solve both of those. Divide by 5. 0 divided by 5 is 0. Here, minus the 1, you get negative 3p equals negative 1, and divide by negative 3. So you have p equals 0 and p equals positive 1/3 because your negatives cancel. And those are your two answers. There's a U-try for you to do. The second part here, if the polynomial is not set equal to 0, you need to get everything on one side first, then factor it, and then set each factor equal to 0 and solve. Okay, so the new part here is get it equal to 0. How do we do that? Well, in order to move from one side to the other, you do the opposite operation. So in negative 3a, we're going to add 3a to both sides. So you have 12a squared plus 3a equals 0. Now what do we do? Factor. What factor goes into both 12a squared and 3a? Let's see, a 3 goes into both, and then a squared and a, we can take an a out. Alright, so 12a squared divided by 3a, 12 divided by 3 is 4, a squared over a is 4a. Plus 3a divided by 3a is 1. You then set each factor equal to 0, 3a equals 0, 4a plus 1 equals 0, 4a equals negative 1, so divide by 4, you get negative 1/4. And on the left, divide by 3, you get a equals 0. So you have 0 and negative 1/4. There is a U-try. So to list out your steps though, when you're doing these, you want to set equal to 0. So get everything on one side. Okay, you do that by opposite operations. And then you factor. And then you set each factor equal to 0 and solve. Okay, so those are your steps to take. If you're one that likes to write down your steps, there you go. All right, moving on, word problems. At a 4th of July celebration, a rocket is launched straight up into the air with an initial velocity of 125 feet per second. The height h of the rocket in feet above sea level is modeled by the formula h of t equals 125t minus 16t squared, where t is the time in seconds after the rocket is launched. What is the height of the rocket when it returns to the ground? Okay, so we have h of t equals 125t minus 16t squared. T is the time in seconds after the rocket is launched, and h is the height of the rocket. So, what is the height of the rocket when it returns to the ground? Well, how do we know when it returns to the ground? Ground level, h equals 0. Okay, that is it. The height of the rocket when it returns to the ground, it's going to be at 0 feet. On the ground, that's going to considered your 0. Part B, how many seconds will it take for the rocket to return to the ground? So we know, since at the ground the height is 0, we put 0 in for h of t. It's 125 minus 16t squared. And now we need to solve for t. Okay, how many seconds is your t value? Return to the ground, that's h equals 0. So now we're solving. From here, you want to figure out what goes in to both 125 and 16. I don't believe anything does, so all you can take out to factor is a t. You're left with 125 minus 16t. Set each factor equals 0. You get t equals 0, which makes sense because you start at ground level. Okay, it's launched straight up in the air from ground level. So at 0 seconds, when you start, you're at ground level. The other part, 125 minus 16t equals 0. Add the 16t, you get 125 equals 16t, and divide by 16. 125 divided by 16 is 7.8 seconds, and that is rounded. It's like 7.8125. So 7.8 seconds. So it takes the rocket 7.8 seconds to return to the ground. Always with word problems, make sure you answer the question. Okay, the next word problem is a you try that one. We will continue going over that in class tomorrow.